Hello, welcome to Math with Kantoma. In today's episode, we are given this problem in probability and we're asked to solve this problem. The question says, the table below shows the number of students in each age group in a class. What is the probability that a student is choosing at random is A, 17 years old, B, not 17 years, and C, over 16 years old. So now this is the table that says the age of students are being given here. We have students that are 16 years old are 7, students that are 17 years old are 22, and students that are 18 years old are 13. So now in this case, we are asked to find the first one, 17 years old. The probability that a student is choosing at random is 17 years old. And remember, in our last class, we defined the classical probability. And in classical probability, we said if there are two outcomes or if there are two events that are going to happen, then the events are mutually exclusive. So now a probability of an event A, we said, is defined by number of possible outcomes of an event A all over the total number of possible outcomes, which is A plus B. So now we're going to use this approach to find the probability that a student is choosing is going to be 17 years old, meaning the probability of a student choosing at random is 17 years old. P of 17 is being defined. Now, applying the concept of a classical probability here, where we set the total number of the possible outcomes of an event A. So now, possible outcomes of an event 17. For now, the student to be 17, we have number of students that are 17 years old are 22. So now, the number of students that are 17 is 22, divided by the total number of students, which is this plus this. Meaning total number of students is 7 plus 22 plus 13, and is 41. So now we write this is 42, not 41. So now, this here is 2 here is 11, 2 here is 21. So we have 11 over 21 as the probability of students choosing at random to be 17. So if you divide this with your calculator, 11 over 21 is going to give you 0 point something. So it is lying is satisfied the first axiom of probability, where we say the probability of an event lying in between 0 and 1 is a dimensionless quantity which lies between 0 and 1. So now the probability of any event will never exceed this limit. It is always within this range. It can be greater than 0, but it can never be greater than 1. It can never be less than 0, but it can be less than 1. So now any number you have from 0 to 1, you know there are infinitely many numbers between this range, 0 and 1. There are uncountable numbers, we cannot count them. We will prove that in some other class. We are going to prove between two real numbers, there are infinitely many numbers, uncountable numbers, which we cannot count. So now, this is the first axiom and it satisfies the first axiom. So now, going back to our question, the second question says, B, that we should find the probability that is not 17 years old. Probability that is not 17 years old. So now, there are two ways to do this here. They said not 17. So I can say this is the same thing as 1 minus probability of 17 years old. 1 minus probability of 17 will give me not 17. Or if it is not 17, then it is either 16 or 18. So I can find the probability of 16 plus probability of 18 years old. So now if I join these two, I'm going to have the probability of not 17. Or I said 1 minus probability of 17 to give me the shortcut. So now this is the same thing as 1 minus probability of 17 is 11 over 21. So now find the LCM here. The LCM is 21. Let me write it here. We have LCM is 21. 21 divided by 1 is 21. 21 times 1 is 21 minus 21 is 21 is 1. 1 times 11 is 11. So 21 minus 11 is 10 over 21. So now the probability of not 17 is 10 over 21. So now let's look at the other way around. If we take probability of not 17, we said it's either probability of 16 or 18, meaning probability of either 16 or 18. So this is going to be probability of 16, we have 7 over the total number of probability is 42 plus probability of 18 is 13 all over 42. So now add this together, we have 7 plus 13 divided by 42. 7 plus 13 is 20, right? 20 divided by 42. 2 here is 10, 2 here is 21. So this is going to be 10 over 21. So you see this and this are equal. So either use this method or you use this method. So you're still going to have the same value or the same answer. Then the last one says over 16 years old. The probability of picking a student at random is over 16 years old. So now when we said over 16 years old, what do we mean? We mean that it is greater than 16. The age range must be 16 above, not 16 inclusive, from 17 upward. 16 is exclusive here, is not inclusive. So now it's either we have probability of picking 17 or probability of picking 18. So I'm going to apply the same process here. So this is going to be probability of either 17 or 18. And probability of picking 17 we said is 22 over 42 plus probability of 18 is 13 over 42. Find the LCM. LCM is 42. We have 22 plus 13 over 42. So 22 plus 13 is 45, right? 35, sorry. 20, 30, 35 over 42. So 35 over 42, 35 over 2 is 5 over 6. So now the probability of picking over 16 years old is 5 over 6, which is less than 0 and greater than 0. Less than 1, sorry. Less than 1 but greater than 0. So that is it on probability here. I will see you some other time with another examples on probability. Thank you for your time. If you have any question, do not hesitate to drop it on the comment section. And if you are visiting the channel for the first time, kindly subscribe, like, and give us a thumbs up. Cheers.